Bring up the topic of motor oils with certain automotive enthusiasts, it's the equivalent of talking about religion and politics for the common man. You don't want to touch it because most of these people already have their brand preferences. They're just stuck in their ways. So we're not even going to try to talk about that in this video. What I will be talking about are some fundamentals, things that hopefully will be helpful to those that are just starting out with vehicles in general, including those that are seasoned veterans or enthusiasts. So to make this video easier to digest, I'm going to break it down into 3 sections. The first section being understanding usage cases, how you use your car now in the future. The second section is going to be understanding oil temperatures and oil pressures. And finally, what is the right oil for your application? So I'm going to start this off by a brief explanation, and that is about 20 years ago when I started driving, the discussion about motor oils hasn't changed online to where it is now. You get the same constant question over and over. What is the best brand of motor oil to use? What's the best additive packs? That discussion has gotten so stagnant. And the true answer to that is, in the past 10 years, true synthetic motor oils in group 4 and 5 have gotten so amazingly good that you can run them 10 to 15,000 miles or more. They don't break down. The additive packs don't break down. You can run them for a long time. So going under the assumption that you're using one of these high quality oils, you really don't have to worry that much about, which oil to use as much as you did 20 years ago. With that said, I've spent over $1,000 and several years going through multiple cars, sending out oil analyses, used oil analysis, virgin oil analysis to labs, including diff fluid, trans fluid, because I want to understand the upper and lower limits of what the motor oil can do in the vehicles that I have. Where does it break down? Does it break down? So that's kind of how I got to this place, which leads us into section 1. This is about understanding the usage case, how you operate your vehicle, what you're planning to do with it. Now, if you're using one of these top grades of oil and you're just driving your Corolla to and from work and you're not doing anything other than that, you're going in the cold and the heat, summer and winter, you can just run this oil forever if your engine's in good shape. But if you're somebody that has more of a sports car and you're driving it year-round and the oil is being exposed to more temperature extremes, sub-zero, or track temperatures, autocross, or drift events, this is where things get a little bit more tricky. So you need to understand how you're using it first, and that will set you up for everything. That brings us to section 2, understanding oil temperatures and oil pressures. Now, to tie this all together, I'm going to give you a quick story. Let's say you took your Ferrari out for the weekend, because most of us own a Ferrari. You have your vape kit, you have your teddy bears, you have your cereal packed, and you want to drive out to Laguna Seca in California where it's 95 degrees. You get there, you look down, and you're like, oh, looks like I left my winter tires on. Now, what do you think is going to happen to those tires on a hot track under those conditions? Well, you're going to destroy the winter tires immediately. They're operating outside of their heat range. They're not designed for high adhesion and high temperatures. Now, conversely, you take that same car, but now you have track day tires on or summer tires, and you decide, well, I'm going to take a drive in the winter. There's snow on the ground. It's 14 degrees Fahrenheit, and you realize while you're in the ditch on the next website for being a douchebag that those summer tires do not work in the cold, and that is because they are operating, again, outside of their temperature range. So the point is, there's not a magic bullet for tires that will allow you to drive in the snow and crazy ice conditions and then go run a track day. It's just physics. It's the way things work in so many aspects of life. How does that relate to motor oil? Well, let me explain. Motor oils, when you look at them, if you pick a really good brand, you can go online and look at a spec sheet on how that motor oil performs, regardless of the grade. Let's just say you take a 0W20 oil from 3 different brands, and you look at the spec sheet, you will see a viscosity at that cold temperature and at their high temperature. And usually that cold temperature is advertised at 32 degrees Fahrenheit, 0 degrees Celsius, or 212 degrees Fahrenheit, 100 degrees Celsius. That's what you know for certain is the cold flow rate and the hot flow rate. And each, even though they're 0W20s, those three different brands might have different flow rates or viscosities at those temperatures. And that's just how spec sheets work with motor oils usually. Now here's why that's so important. Those spec sheets will not tell you what happens to the viscosity of the oil outside those temperature ranges. So if you're operating the vehicle in extreme cold or extreme hot, you don't know what the viscosities are going to turn into. And that's where it becomes kind of tricky. Now let's take a look at these two cars. You have a Toyota 86 or FRS or GT86 BRZ, whatever you want to call it. Straight from the factory, they spec'd out 0W20 oil, which is more designed for efficiency. It's economical, it brings better fuel economy, and it's great for low temperatures. Conversely, on the other side of the spectrum, you have a BMW M3, which from the factory ships with 10W60, which is designed for high temperature. They know that this motor is high strung, has extremely high tolerances. It's more of a race-bred engine. They know people are going to be driving this on the track, so you need a motor oil that is going to keep its viscosity at high temperatures. Now, as that relates to knowing oil temperatures and pressures, let's talk about this. We know you can drive year-round on a 0W20 oil, but the Achilles heel of a thin oil is the hotter it gets, and outside the specifications, as soon as you take this out of 212 degrees Fahrenheit and you get it into the 230s, 240s, 250s and onward, that oil gets thinner and thinner and thinner. And that 20 weight, or that hot temperature viscosity, starts to plummet, and it turns more into water, for example. So that 20 weight is no longer a 20 weight when you're getting up in temperatures, regardless of your motor oil brand that you choose. Now, with the BMW M3, the same thing's going to happen. Once you exceed that 220, 230, 240, it's going to thin out, but it's not going to be anywhere near as thin as the 0W20 would be at that same temperature. Now, I took a supercharged FRS, and we put about 4 hours track time on it running redline 0W20. Now, forced induction, something it wasn't meant for. It had an oil cooler, but we saw temperatures climb over an hour session to 265, 270 degrees. So I knew I had to send this oil out to a lab to find out what was going on with it. I expected to see wear materials. I expected to see a breakdown in the additive packages, all that stuff that you would expect to see from oil being used in extreme conditions. Sent it out, and the oil analysis after 4,000 miles and 4 hours track time came back perfect. In fact, the lab said they couldn't believe how perfect the sample was given the conditions. No breakdown in additive packs, no wear materials. So what it proved was you could run a 0W20 oil on the track at high temperatures well outside its heat range, no problem. Absolutely not. Because what that oil analysis didn't tell me was that the oil pressures of the motor were catastrophically low, to the point of skimming bearings, doing catastrophic damage to that engine. And that's something that you wouldn't know unless you were monitoring oil pressure, because as that oil thins out, the pressure keeps dropping and dropping. Now here is the complete other side of this. This BMW runs 1060, as I already said, which means it will hold up to the high heat no problem. But what about the extreme cold? In my review, I said that I would never run 1060 in the winter. And of course, on Reddit, people start going off, this guy's a fucking idiot. I know my grandmother's sister's boyfriend who runs 1060 oil in an E46 M3, and they have no problem, which of course is not the same motor, not the same car, be that as it may. The reason why I said I would never run 1060 weight oil is because it just does not flow at cold temperatures, namely in a car with like this that has some of the tightest bearing clearances of any production motor really in the world. So you have oil galleries, all the tight clearances, all the things that you need oil to flow in the cold. So here's a quick example. I took 3 different motor oils, stuck it outside in sub-zero temperatures to show exactly what that oil looks like being poured through a funnel into a glass jar, and what it would look like when you start your car in the cold. we're going to start with 10W60 that is spec from BMW. Now, as you can see here, pouring this oil is literally a joke, and why I said I would never run it in the winter. It's not designed to be run in the winter in extreme temperatures, and it's much like the tire comparison I made. It will not even pass through a 1/4 inch to a 1/2 inch funnel hole into the jar properly, which, you know, imagine starting your motor, trying to get this oil through these oil galleries and the tight bearing clearances. You're relying on that film that was left behind to protect your motor, and it's just, you can do it, but you shouldn't. Now we take a look at the Euro spec oil that so many people use and substitute in BMWs, Ferraris, all these different cars use it. This Pennzoil, you know, even a thinner oil, a 5 winter weight oil, still has a hard time flowing in these sub-zero temperatures. It's better, but, you know, again, it's not the greatest. And then we take a look at 0W20, which how well it flows in the cold. It's almost hilarious, the difference between the two. I mean, this is obviously the optimal oil for cold temperatures. Now this is getting a bit long-winded, but section 3, what motor oil should you use? And you're going to see so many videos, so many people from brand reps. Everybody wants to give a non-answer because, well, you should just go with what the manufacturer recommends, right? Well, here's the thing. If you take this GT86 or any car with 0W20 oil to a track, and you know for certain that you're going to be having high engine oil temperatures, 240, 250, 260, no oil cooler, you don't want to run a 0W20 on the track. You want to sub in an oil for those conditions that's going to hold its viscosity. And it's as simple as and complicated as that. If you're going to go back home and you're never going to get those temperatures back up with the oil, then you're going to want to sub back in 0W20 for your daily drive. Now, looking at a car like the BMW M3, as costs come down on the used market, if you're operating a car like this in the winter, you don't want to be running 10W60 because it wasn't designed, its best performance is not in 10 degrees Fahrenheit. So if you know you're only operating between 0 and 32 degrees Fahrenheit, then you can sub in a thinner oil, a 5W or a 0W 40 or a 50, whatever you're comfortable with, because you know you're going to be operating in that window that's outside the specifications. That is okay to do, but you have to know, again, your usage case, what your oil temperatures are, and preferably also know your oil pressures to be safe and to know what the best oil is going forward.